Yes, let's get started. So good morning, everyone. My name's Adele Carpenter. I am a software engineer at Trifork Amsterdam. So if you're thinking that's a very familiar sounding Dutch accent, well, you're right. I'm actually a born and raised Gippsland girl. And I'm so thrilled to be speaking not only in my home country again, but also in my home state. For the first time, actually. I've spoken in Sydney before, but not Melbourne. So in my work at Trifork Amsterdam, I spend most of my time building and maintaining Java and Kotlin applications for the educational sector, although more and more lately, you'll find me trying not to cause too much damage with React in the front end. So I'm really curious, has anyone here seen a talk from me previously? Maybe? All right, cool. No, that's absolutely fine. I'm a relative newcomer. I am based on the other side of the world, and there is so much quality content out there. So really, thanks so much for coming and supporting me. And I do really hope that you get a lot out of this talk and that you do enjoy it as much as I enjoyed writing it. So I have spoken before actually about rewrites, and I used the example of Lika, a junior engineer who has just joined a team on a large and aging Java project. And she's feeling overwhelmed at the sheer complexity and enormity of the project, and just feels that the only way out of her current nightmare is a rewrite or report. But luckily she's surrounded by an awesome team, and they help her see that a rewrite is rarely a good choice. So as a team, they decide they're going to move the project forward by taking small, consistent steps in the desired direction. And I 100% stand by that talk and that advice, but it did get me thinking, is there ever a time when a rewrite is a good idea? And it turns out that that was a little bit serendipitous, because around the time that I started thinking about this, my team and I were faced with this question on a customer project. So to give you a little bit of a background on Trifork, we are a project-based consultancy, and the team that I work with are a little bit unique in that we have a product as well, the assessment delivery engine or exam player, which we deliver to a small number of customers, each of which have a custom implementation on top of our core product. So basically it can pass assessments that comply with a certain specification and then play the assessment for the student or the candidate. So it renders the questions, manages the time remaining, selects the next question, and calculates the results. So we have the product part, and the custom implementations are the project part. Now, recently, one of our customers, the one with the most custom of the custom implementations, was starting to get a little bit frustrated with one of our applications. And if I'm to be really honest with you, we shared their frustration. Now, I mentioned already that one of the features of our product is that it selects the next question. And that seems pretty straightforward, right? You have a list of questions, you pick the next one, you go from index 2 to index 3 in a list. So, no, not in all cases at least. So for this customer, we actually have a dedicated web service for selecting the next question. And at the core of this web service is an open source C++ service written by a top researcher in the field of automated or computer-based student assessment. So her profile actually says automated testing, but I think for this audience, such language is a one-way ticket to a misunderstanding. So the service that she wrote is an implementation of item response theory. Now, item response theory is a family of mathematical models in psychometrics, which is the science of educational and psychological assessment. And the models of IRT are used to design, analyse, validate, and score assessments. So to make things a little bit more concrete, you can think of an item as a question of certain difficulty, ranging from low to high. And then, as you would expect, an assessment is made up of a range of a selection of these items. And the point of the assessment is to determine the student's knowledge of or ability related to the topic of the assessment. Now, in a standard assessment, everybody gets the same questions. So for an average student, some of the questions will be way too easy and some of them will be way too hard. And for some students, all of the questions might be too easy or all of the questions might be too hard, which makes the assessment kind of useless for them. So One of the cool applications of IRT is that you can estimate a student's ability or knowledge on the fly and deliver a question at that moment in the test that's at the right difficulty level for them. And this can make the results of the assessment more meaningful. It also makes the assessment appropriately challenging and hopefully more interesting for the student. I mean, as interesting as taking a test could be. Now, I want to make clear that the C++ service wasn't bad. The researcher that wrote it will forget more about IRT and statistical validation methods than I will ever know. But we did have some problems running and maintaining it, which was the service that, while reliable and fast, was essentially a black box. We sent it data and it sent data back, and we did not have the skills in the team to verify the results. We kind of just trusted that it would work and select an appropriate next question for the student. Now, initially there had been some simulation testing done, but that was done by an external party. So adding features was just something that we didn't do out of fear that we would ruin the validity of the underlying algorithms. And this was a key source of frustration for the customer, that the service, while useful, was relatively stagnant. Now, of course, in a pinch, we could contact the researcher that built the app, but she's a busy woman and maintaining this service is absolutely not her highest priority. And adding to this, the service itself was actually not a web service. So years ago, a developer on the team was keen enough to write a wrapper around the algorithmic core, which gave us 4 endpoints that we could call. But our only option if we got an error was simply just to check our request and retry. Further, logging in the core model was non-existent. So for example, if we had an item that had an unexpected difficulty, which could be as simple as a typo, there was no logging to tell us what was wrong. And since the core model primarily dealt with integer arrays, in order to build the request, we had to translate all of our item data into those arrays, which left our requests essentially meaningless. So yeah, check your request and retry. How? So if there were any issues with a particular item, it was almost impossible to figure that out. And because the service is stateless, we needed to send the entire item bank with every single request. So we're talking 60,000 lines of JSON. Now, if you did decide to be brave enough and open up the code base, you're presented with code that was written in the language of the academic domain. So we had names like this. So let's go through them quickly. So APAR, that's not too hard, a parameter, but what does that mean? Item difficulty, obviously. And then we've got BPAR, B parameter, real terms, item discrimination. So how well does the item help estimate the student's ability? CurSeg, current segment, not too bad, but still not explicit enough for my liking. Theta, another one from academia. Theta is actually the ability of the student, so that's the thing we're trying to estimate here. So now that you know theta, can you yell out your best guess for warm theta? Yeah, so that's actually a really good try. That's sort of what I thought, but it's actually called warm theta because Warm was the last name of the guy that proposed this method of estimation in a paper. Not because it's a close guess, although, you know, since it is an estimation, you know, it is a close guess. It's a warm theta. And now we round out the list with cluster and category. Now, again, these are academic terms. We use the term friends group and domain in the team, respectively. So far, I hope that I've made it pretty clear why the current service is problematic. It's a black box, it's hard to reason about and debug, and trivial changes take a long time and include a steep learning curve. So maybe not so obvious at this point is what makes the service a good candidate for a rewrite. Does anyone have any ideas? What makes it a good candidate? That's fine, all right, so it's stateless. So it receives data and returns data, so we don't have to worry about a data layer or a front end. It has a well-defined scope or footprint, so we need to expose 4 endpoints to one service only, and it's a small part of the entire project. So this reduces the risks or potential downside of a rewrite attempt. Now, this brings me to what, in my opinion, are the 3 most compelling reasons to entertain the idea of a rewrite. Personally, I think you would need all 3, but you would want to see at least 2. And the reason I'd like to have all 3 is because they each look at the question of should we rewrite from a different perspective. But first, I want to start with a reason 0 because, well, we're developers, so we are 0 indexed by design. But also because without a reason 0, then all of the other reasons are irrelevant. 0, there is a desire to functionally change the application. Because if an application is running reliably in production and there is no desire to change the functionality, then I would be hard-pressed to come up with a reason on why you would rewrite it. You might see some odd behaviour here and there, and investigating when that happens is the bane of your existence for a day or 2. But if those incidents are few and far between, and there's no desire to change the functionality of the app, then that's probably just a reasonable cost of running it in production. Because as long as you can do the bare minimum to keep it running, like bumping versions when necessary, using long-term support versions where possible, the status quo is probably fine. And if this is the case, but you still wish to rewrite, then you probably need to dig down a few layers on why you would want that, because it's probably about you and not about the application at all. For example, you're just not comfortable being responsible for something that you do not understand well. So on to the first reason why you might entertain the idea of a rewrite. And we're going to start by looking at the current service as it is in the context of the team responsible for it. There are no small steps to be found. So I stated already that I 100% stand by the advice to focus on consistency over perfection, to take small steps to evolve your application. But there's a big implication here though, and the implication is that the small steps are in fact small. So let's take the example of bad logging in my Teams project that I mentioned earlier. So a great quick win would be to add some logging, right? So in this case, given that we are a JVM-based team working on a C++ service, that would require running the project locally, learning how C++ logging works in C++ works, and actually learning about a lot of stuff that the JVM abstracts away, like memory pointers, identify an appropriate library and the dependency, learn how dependency management works in C++, learn the basics of the build tool, and then pray that it runs again. Now, for some teams, adding logging to this application is indeed a trivial change. But for a team that lives mostly in the JVM, you need to ask, is the steep learning curve worth it? And at what point does something move from being a small step to being a large undertaking? I guess I also think it's a little bit simplistic to say that adding logging is always a small step, and the same goes for other small steps such as improving test coverage, renaming, extracting methods, and improving abstractions. Whether they are really small or not is up for your team to decide. It's not up to me or anybody else. But what I can do is I can offer some advice on how you might approach these discussions, and that is to be aware of your bias and to look for evidence that proves yourself wrong, rather than having a wish and then trying to prove to yourself that it's a good idea. This will help you minimize the impact of confirmation bias in your decision making. So, for example, if you are currently feeling the pain of a legacy code base, you're probably a bit more biased towards rewriting the application in a way that's familiar or that makes sense to you. So in this case, I would advise you to look for reasons why keeping the current application in production is a good idea. So you need to ask yourself questions like, why should I keep the existing code base? What opportunities exist to improve it? Now, in our case, being the skeptical duchies that we are, we were the opposite. we really saw a rewrite as a last resort. So our line of questioning was more around what pain are we experiencing now that can only be resolved by rewriting or porting the application? And are the opportunities to improve the application really there? And how much work are they really? And is that really less work than a full rewrite given the makeup of the team? So this brings me to reason 2 on why you might consider a rewrite, which looks at the team in the context of the organisation. The skills are not in the team and you do not wish to acquire them. So does the team have the skills to consistently improve the service? And if not, does the company wish to acquire these skills? Because we've already established that a small step for one team could be a big step for another team. So you could be forgiven in thinking that this reason is basically the same as the first. But the key difference here is the second part of that sentence, and that's what I want to focus on here. No wish to acquire the required skills. So this is about maintaining applications that are in line with your company or project's tech stack. And this is a completely valid reason to consider rewriting or porting an application. And it certainly was a big reason for us. So at Trifork Amsterdam, when it comes to the back end, we are very much a Java Spring shop. And yes, that includes Kotlin as well. We incorporate tools and technologies that are within that ecosystem, or at least very closely related. Now, of course, we're a team made up of individuals with different backgrounds. So, of course, there is some .NET experience, and if you go wise and grey enough, you'll get some C++. But our bread and butter is Java Spring, and that is not going to change for the foreseeable period. Because we're a small company and we run many of the applications that we build, so keeping the tech stack manageable is actually a strategic advantage for us. Now, that doesn't mean that every new service we write is in Java, especially if startup time, memory use, or application size are priorities. But it means that while we do believe in the best tool for the job, we also know what our strengths are, and we look for good enough tooling that is complementary to our existing tech stack. Now, I'm going to digress a little bit here, but this also helps us avoid the pitfalls of resume-driven development, because considering a rewrite is a time where you can really see RDD come out in full force if you are not careful. Now, as the name suggests, resume-driven development is making design and tooling decisions with the primary goal of adding content to your resume. And it often manifests as wanting to play around with newest technology, even if that technology is completely incongruent with the rest of your project or company's tech stack. So if you're considering a rewrite and your eyes light up at the possibility of doing something completely new with an unfamiliar but exciting technology, you know, that's just a moment to take a minute and ask yourself, do I really need a rewrite, or do I just want a playground for new toys? Or, to keep the analogy going, a kitchen for new desserts. So, by now, we've looked at the service in the context of the team and the team in the context of the organisation, and that brings us to looking at the service in the context of the entire application. The service is small and the scope is well defined, or it can be broken up in such a way that this is true. So, earlier we considered whether the opportunities to exist the current code base as it is, and here we are looking at the suitability of rewriting the application in deployable chunks. Now, this is all about minimising risk, minimising the risk of wasting resources building something that never sees the light of day. Now, in our case, our rewrite application was actually pretty well defined. It was a stateless service that had a very small, albeit important role in the context of the entire application. However, we still ended up with 3 deployable chunks. It absolutely was not a 3-2-1 Big Bang cutover. Now, of course, if the application that you'd like to rewrite is larger and more central to your system, then it's even more crucial to have a plan on how you will break your rewrite candidate up into smaller deployable chunks. Having a small and well-defined scope is crucial so you can see the benefits of your rewrite as soon as possible, because among other things, this reduces the risk of your project sponsors pulling the plug on the project entirely. So back in 2004, Martin Fowler was the first to coin the phrase strangler application. And as an Australian, I find this really cool, and I hope you do too. So Fowler was actually inspired for this metaphor during a trip to a rainforest in Queensland in 2001, where he encountered the strangler figs. So you can see it here on the right in the front of this photo. Now, if you're not already aware, there's so many parasitic plants in Australia, it's hard to keep track of all of them. So strangler figs are a parasitic plant that seed in the upper branches of the tree, and they eventually make their way down to the soil. And in this process, they envelop the host tree, eventually strangling it, after which the strangler fig remains in its spectacular glory. And a strangler fig application works in much the same way. So this image is based on one from Paul Hammett's blog, which is conveniently linked to from Fowler's original article. And Paul is an ex-thought worker, contributor to Selenium, strong voice in trunk-based development, and branch by abstraction. But before we discuss this image, here's the QR code to Fowler's original article, which you can take a picture of while I take a sip of water. So Paul's blog also links to a couple of resources as well, including an excellent paper by Chris Stevenson and Andy Pols. So the rabbit hole that you can go down from Fowler's original article is well worth it. I recommend it. So back to the image here, and it shows a simplified evolution of a strangler fig web application. Now, while harder in practice, certainly, than in theory, essentially you rewrite a small portion of your application and you run the rewrite alongside the original app. And slowly over time, as you rewrite more and more of the app, eventually all traffic gets routed to the new app. Now, taking this approach makes it possible to weave in new functionality as you go, which can really keep the stakeholders happy and build trust in the rewrite project, and most importantly, keep the rewrite project alive. Now, how you go about carving up your application to rewrite will depend on a lot of factors, and it can be really, really tricky to know where to start, but you can make use of a handy concept from extreme programming called a spike. So essentially, a spike is an experiment to explore a possible solution to a new problem, and it's so called as a spike because it is end-to-end and very thin. Now, a spike can be functional or technical, but it's usually best to start with a functional spike. So identify a pain point for your users in the current application and build a proof of concept to tackle that pain point. Now, ideally, you would try to find this pain point from your users directly, and it's like bonus 1,000,000 points if you do. But it's like totally valid also to just nominate a member of your team to act as a customer proxy. Now, in our case, our first users were the researchers at the customer, and together we decided that the first deployable chunk would actually be a number of APIs so that it would be possible to interact with early versions of the item selection models. Now, the final application would actually combine 3 internal steps into one endpoint, but exposing the internals early, like this, meant that the researchers could query the model directly, run simulations, and verify that the model did what they expected it to do. And if it didn't, importantly, they could provide feedback. Now, delivering this value early, even if it was not production ready, was important in building the trust and keeping the project going with full support of the key stakeholders. And further, it provided us with invaluable information on how to get our first chunk to production and what the scope of that first chunk would be. So when the question came up in my team of do we dare to rewrite, despite our strong bias against not rewriting, when we considered these 4 reasons, the answer actually became pretty clear. And I am actually happy to report that we have decommissioned the last instances running the old application, and we are running the rewritten application 100% in production. And I think that that's actually a pretty cool milestone. So I'd like to share a little bit more about how we approached the project and what we learned along the way. So the first step was actually an audit of what the current model actually did. Now, along with many discussions with the customer, the audit included meeting with the researcher who wrote the original application, simply to learn more about what the app does and how it does it. And on the slide here is just like a brief version of the results of that audit. Now, the audit was really enlightening as we discovered how many features the app actually had, and interestingly, that we weren't even using all of them in production. So, for example, there was a feature called content balancing, and what that means, if you have questions or items from different topics in the same item bank, then you can make sure that an even number of questions from each topic or category are shown to the student. So basically the model would determine what category needs to be shown next, and then of these items, which is the best match for the student's ability. However, in production, there was actually a separate item bank for each category. So we didn't need the content balancing feature at all. The customer did express a desire to use that functionality in the future. So it was added as a potential requirement for a later release, but we deliberately left it out of the planning for version 1. And this phase of the project was actually quite interesting as we discovered how powerful the original model actually was and how little of it we were utilising in production. Because had we uncovered all of these layers and learnt that we were indeed using all of them, then this would have been a really good moment to go back and reconsider whether a rewrite was in fact a good idea. Because I ask you to remember point 3. The scope is small and well defined. Now, that's not just something that you think about up front, that's something you need to keep in your mind as you go. Because I think it's a huge trap for developers, especially if we've just joined a project, say, less than 12 months ago, and it's actually a little bit Dunning-Kruger. We start to understand just enough of the domain that we think, oh, why is this so complicated? If we could just start over and simplify the data model and abstract that over there and use some newer technologies while we're at it, then we could move faster and enjoy working on this project much more in the process. But the truth about many production systems is that they are the way that they are for a reason. You are not smarter or more insightful than your predecessors. So sure, things do evolve over time and decisions made in the past may be suboptimal given today's context, but often there is much more to architectural design decisions than what is immediately apparent. So I would say that if you do choose to pursue a rewrite, treat the first phase as a discovery or a feasibility stage, even if you are writing code already. Prepare yourself mentally to walk away if things turn out to be bigger or more complex than you first imagined. So after a few meetings, we had an overview of the features and requirements for version 1. And it was decided that while the new system as a whole would be a drop-in replacement for the old system, the underlying statistical models would also change. Now, this was for a couple of reasons, but one of them was to make the model extensible in the future. So, for example, the old model made use of one item quality or parameter to estimate the student's ability. So that is the item difficulty. However, under item response theory, there are at least 2 other parameters that can be used. And the other key reason for the change in models was, as mentioned, that there were just features that weren't being used at all. So the combination of unused features plus the desire for future extensibility led researchers at the customer to decide to rewrite the underlying statistical models. And that decision did impact our approach to testing a little bit, because in the end it was the role of the researchers to validate their new model against the old service. They then provided us a list of inputs and expected outputs, which we just added to our test suite. And overall, it was a really, really nice collaboration as we both analysed the existing application code from different perspectives. So at Trifork, we looked through the lens of like inputs, outputs, exception handling, and edge cases, whereas the researchers were more concerned with the mathematical models and psychometric validity of the model. So when we at Trifork were ready to start development of the application itself, we were provided a model from the researchers, which was written in R and accompanied by mathematical notation. And this meant that the team members could work on understanding the model in a way that was most natural to them. So personally, I preferred the mathematical notation. It was a lot more natural to me and it helped me figure out the R code. However, for some of my colleagues, the opposite was true. And I want to clarify something here, because when I say we were handed a model, really that happened in stages. It wasn't like the researchers sat in a room for like 6 months and then were like, here, put this in production. The researchers were fully aware that we wanted to use Kotlin. They did their own investigation of the libraries that were available and they discussed them with us. I mean, the upside of working with PhDs is they are very conscientious. So now, as for the reason that we chose Kotlin for the project to begin with, I hope that you already have a couple of ideas as to why we made that choice. So as I mentioned already, Trifork Amsterdam is a Java Kotlin Spring shop. It's our bread and butter, it's what we do. And in my team in particular, we have a very strong preference for Kotlin. So believe it or not, I actually learned to program in Kotlin. So in my opinion, choosing Kotlin or Java within the context of a Spring Boot application is really little more than a personal preference. Like, sure, your preference is wrong if you choose Java, but everyone is entitled to their own mistakes. Now, as for the choice of Spring Boot, the downsides of the framework, namely the size and the startup time, they were going to be a non-issue for us. It's a good enough choice in the context of the company and the team. So having made our language choice of Kotlin, and together with the researchers, we looked at the numerical packages available to see whether they would be a good fit for building the model. So JetBrains have been pushing Kotlin for data science a little bit, so we knew that there was plenty of resources and libraries out there. So 2 options that came up during our search were multi-K and Smile. So multi-K is a multi-dimensional array library, and SMILE stands for Statistical Machine Intelligence and Learning Engine. Now, immediately SMILE seemed a little bit overpowered for what we would be doing, but multi-K looked like a solid candidate. So at Trifork, we went back and we did some small experiments. And what we found was that while multi-K would do a fine job, it didn't really add anything extra for our use case. Now, it did make light work of calculations on multi-dimensional arrays, which we most certainly would be doing. But after a bit of consultation with the researchers, we found out that the arrays in the final model would only be 2-dimensional. This is a very important distinction because 2-dimensional space is quite straightforward. 3+ is where it starts to get tricky, because another way to think of a 2-dimensional array is a list of multi-parameter objects. And I'll show you what I mean by going through an example in the next few slides. And then after that, we're going to nerd out a little bit on some mathematics, on a concept many of you have probably forgotten, perhaps deliberately. Don't worry, I'm going to keep it light, I promise. And this discussion is really nice to have because it gives us a bit more context for the reason we chose the tech stack that we did. So diving into the example now, in Kotlin we can simply define a data class of multiple primitive types. This is a trivial example using sales at a waffle store, just to keep the domain as simple as possible. And the very first time I gave this talk was in Belgium, so it has to be waffles. Now I was going to change this example for a local audience, but I decided it's actually just fun to blame Belgium for no reason. So if you don't like the examples of waffle, you can blame Belgium. And this is probably a really good time to mention that the sibling rivalry dynamic between the Netherlands and Belgium is basically the same as Australia and New Zealand, just with more waffles and less sheep. So let's say you've got two kinds of waffles for sale at your waffle store, stroop and Belgian. So stroop is Dutch for syrup. And they're each for sale at a different price. And I know I just came for Belgium pretty hard, but that's my right as a Dutchie. I'm also allowed to go for New Zealand. That's my right as an Australian. So to be fair, I have made the Belgian waffles more expensive in this example because they are actually, much to my disappointment, way more delicious than the stroop waffles. And so yes, I am a traitor to my adopted country. Please don't tell them. I would like them to let me back in. So anyway, after you have the data for each of your products, then you can define the weekend sales of your data of your waffle store as a list. And to upgrade this code a little bit, you could lean into the type system and you could define separate types for quantities sold on each day of the week, for example. And we use this value object pattern a lot. It means that you never confuse the sales for Saturday with the sales for Sunday during your calculations, as they are different types. And the compiler will tell you right away if you're trying to use a Saturday value where you should be using a Sunday value. Now, here this distinction doesn't really matter because the price is the same on both days. But this extra bit of type safety saved our butts more than a few times. It also reduced the number of test cases that we needed to write. So just to give you a little bit more of a concrete example, in our model, the item difficulty and the item discrimination are both doubles, and they are used side by side in the code base to determine which item is the best fit for the student at a certain point in the assessment. So by declaring them as separate types, we not only get the benefit of naming, but we could be confident that we were doing our calculations on the intended parameter and therefore prevent erroneous results and hours of frustrating debugging. So back now to our waffle example and continuing on, you can calculate the daily sales of your waffle store using the syntactically beautiful sum of function, and you end up with 105 euros of sales on Saturday and 94 on Sunday. Now, just for a quick comparison, let's just have a quick look on how you would represent this calculation with the multi-K library. So the cool thing about multi-K is that it allows us to use matrix notation so that we could use the same language as the researchers. So we can represent that same waffle store data by first declaring the prices of the different kinds of waffles as a 1x2 matrix, then declaring the daily sales as a 2x2 matrix. So on Saturday we sold 15 stroop waffles and 25 Belgian, and on Sunday we sold 20 stroop waffles and 18 Belgian waffles. Then we find what's called the dot product of the prices and quantities, multiplying the row of the prices matrix by the columns of the quantity matrix, and then adding the results together. And in doing this, we come out with exactly the same result as the previous method, 105 euros of sales on Saturday and 94 on Sunday. Now, you may have a different preference, but for our team, using the features of the collection library on a list of type-safe objects, as we saw in the previous slides, was much more natural for us than multiplying two-dimensional arrays or matrices, as you see here. Now, sure, this is much more lines of code, But to me, it's much more readable and it trends towards self-documenting. So indeed, it turned out that we could do everything in the Kotlin standard library, and the researchers' model was written in R with that in mind. Now, they still use two-dimensional arrays or matrices in their models, but we could easily rewrite those as lists of multi-parameter objects, and with the experience gained during our experiments with the multi-K library, that actually gave us all the tools that we needed to do that. Now, I want to move on to the last section of the super nerd segment, which is the calculations themselves. So knowing that we wanted to stick with the Kotlin standard library, the researchers stuck to approaches that relied on basic scientific methods when formulating the model. So in the end, there was nothing more scary than Euler's number E and the natural logarithm. And the Kotlin math package had us covered there. So just as a quick example, and as a little refresher, for some of you, this might be the first time seeing it, no worries about that. As I said, I'll keep it as light as I can. And I did promise geeking out in the abstract. So if you didn't read the abstract, that's not my fault. So, as I mentioned, this just provides a little bit more context to our tech choice. So this is Euler's number E and is the base rate of growth shared by all continually growing processes, and that gives it a central role in many domains, from investing to probability to radioactive decay. Now, just like pi, it's an irrational number with a set value. So what do I mean by that? Well, in mathematics, irrational means that there's no limit to the number of decimal places it has, and there is no repeating pattern in its numerical value. So here, to make it a bit more concrete, I've written out E to the first 150 decimal places, although the first 3, I would hope, would look somewhat familiar to you. Now, the other cool thing about E is that it's its own derivative. So the gradient of a function of E is the function of E. And that's not pointless trivia either. That's a really, really, really important property that we were able to exploit in our model. And if we go one level deeper now, the value of E is the limit of the following expression. So if you keep adding these fractions, as n approaches infinity, you will get closer and closer to the true value of E. Now, just the last little tidbit before we move on, given the exponential properties of E, Euler used the letter E simply to refer to exponents, but by one of those cool coincidences, like how Thomas Crapper is best known for his work on toilet-related patents, the letter is just now associated with his name. So E for Euler. So, in terms of working with E in code, in most worthwhile languages, and which, yes, even though I am a Java developer, I would consider C# a worthwhile language, you get a convenience function exp, which is e to the power of the past value. So x3, e to the power 3 equals 20.08, and you also get the natural log, which is the inverse of the growth function. So the natural log of e to power is approximately equal to 3, and this inverse relationship is another useful property which we could exploit in our model. So these two functions, combined with other basic stuff like to the power of, absolute value, and square root of, ended up being the core of our model. So while the maths that was involved was far from straightforward, the researchers were able to come up with a valid solution using pretty straightforward mathematical expressions. And this meant that we could write the core model in a pretty clear and maintainable way with just the standard library, which I think is pretty cool. And it also validated our choice to pick the stack based on what was good enough in the context of our team, rather than trying to find the best language packages for modeling item response theory. So I'll just take a sip of water, and I'll warn you, we're going to do a really hard pivot now, a really hard pivot. You're going to see the next slide, and you're going to be like, oh, she's nuts. And while that may be true, it's going to make sense. So, as I said, shifting focus now, I'm going to use the last part of this talk to shamelessly throw in some photos of a cute dog while I reflect on taking my first steps into a leadership role as a junior dev. Now, one of the things I really like about working at Trifork Amsterdam is that we don't really have fixed roles or titles enforced. We like to focus on the individual, and if there's an opportunity that comes up that matches your skill set, have at it. So even though I only had a couple of years experience as a developer when this project came up, I ended up taking a leadership role in some areas, and spoiler alert, it had mixed results. So in my study of civil engineering and economics, I actually did quite a bit of calculus and linear algebra, and I had some experience with packages like MATLAB and Mathematica, and I am by no means a mathematical wizard, but it is a solid enough background, and at the time it was the most maths experience in the team, and adding to that, I'd be working with the customer for 2 years, so my domain knowledge was solid as well, and the planets had seemed to align. Now, having suffered mega imposter syndrome for the last 2 years, mostly fueled around insecurities related to not having studied computer science, I jumped at the chance to show off these different skills that I had picked up along my unconventional path to becoming a developer. And I came to those first meetings with much enthusiasm and lots of questions. So what model do you want to use? Where do we get this number from? How do we go about solving for that parameter? Do you have a paper I could read? And to be honest, I was probably quite insufferable, but just like an excitable puppy accidentally knocking over a pot plant with a stick that's much too large for her, I got a little bit of a free pass and most of my questions were answered. And even though I didn't understand all of the answers all the way through, that didn't matter. I could get my head around the basics. We had a probability function which we couldn't solve directly, but we could estimate iteratively using the boundary closure approach. As I already mentioned, the customer was kind enough to provide a working example in R. Now, R is not a language I know well, but given enough time and Googling, this was actually pre-ChatGPT, I could figure it out. I also had access to the service that we were replacing. Again, not a C++ developer, but by taking my time and annotating as I went, I could understand it enough to ask the right questions, get the right feedback, and form a sound understanding of the domain. And it was pure joy for me, figuring out how to turn mathematical formulas and R code into production-ready code. You know, the kind of joy you see in a dog when she plays with her favourite ball. And we're a small team, so in the beginning it was largely my task to put the proof of concept together. And that worked for a while, until it didn't. I was having so much fun that I didn't include as many people as I should, as early as I should. Now, don't get me wrong, the project absolutely was a team effort, but the proof of concept of the core model was a pretty important part of the work, and I kept too much of that part to myself early on. And I had documented some stuff, but what I hadn't documented was all the loose ends that I still had in my head of exactly what needed to happen before we could go to production. And well, you know, it was summer by now, so like a good European, I went on holiday. And I'm a firm believer that timing is everything in life. So you guessed it, while I was on holiday, the external pressure started ramping up, pushing us to get the first deployable chunk into production. And all those to-dos that were in my head were still in my head, and only in my head, on a beach in Greece. And I came back, and it had been a chaotic 2 weeks, apparently. The worst part was that some of the main issues that my team faced were non-issue to me. Sorry, guys. So yeah, that was a big lesson. Leadership is more than knowing what's going on and being available to answer questions. I don't like to assume that others don't know things. I know that my colleagues are as smart as hell, and I don't want them to feel any other way. And I think this comes from my own feelings about my intelligence and my identity, that like if I'm not smart, then who am I? But that philosophy is ultimately unhelpful and unfair to others. If people get offended because you want to keep track of the details, well, that's on them. So definitely, if I had my time over, I would be proactive in keeping the lines of communication open within the team and set an example by documenting everything as I go. Even if it's just brain dumping in a ticket, as my Uncle Fred would say, it's better out than in. And one final note on this, because I think it's really important to hear, even if it's just from some rando on stage, even though I made mistakes during my first toe dip into leadership, I am happy that I did it. I learned a big lesson that's been invaluable as I organically take on more leadership responsibilities as I progress in my career. So I want to make sure that you hear that message. If an opportunity comes up for you to extend yourself a little bit, go for it. You know, what are some qualities or experiences that make you a good fit, even though you don't have any direct experience in this exact task? And who can you ask for support, either in your team or outside of it? Speaking from my own experience, imposter syndrome never goes away, but you get better at shutting it up. And the way you get better is by proving to yourself that not only can you do hard things, but that you can dust yourself off and try again if things don't go according to plan. So, to wrap up, let's revisit the title of this talk. Are rewrites always a bad idea? Yell out what you think. No. I set you up here purely just because of how I've posed this question, right? The answer has to be no, thank you. Simply because there are no certainties in life. Sweeping generalizations are always wrong, at least some of the time. So maybe a better question is, are rewrites generally a bad idea? And here I will give a resounding yes, but they can be a good idea sometimes. And in this talk, I provided you the top reasons why you would entertain the idea of a rewrite. Now, ideally, all of them would apply to your rewrite candidate, but personally, I would like to see reason 0 and at least 2 others. So, reason 0, so called because without this one, then all others are irrelevant. There is a desire to functionally change the application. So if you're not touching the application in any way and it's running reliably and securely in production, why does it need to be rewritten? On to reason 1. There are no small steps to be found. You've determined that the application does require some ongoing development, but the code base is in a state and there are no quick wins for your team to start improving it. The skills are not in the team and you do not wish to acquire them. In other words, improving the application requires climbing a steep learning curve towards skills and knowledge that the company does not need and does not want. The service is small and the scope is well defined, or it can be broken up in a way such that this is true. And this means that you can deliver value and get buy-in early, and the application and the potential downside of the rewrite project is small. Now, if despite the odds you have determined that your application is indeed a good candidate for a rewrite, then you can take some small steps towards that goal. So start by conducting a thorough audit of what the current application does and what you will be rewriting. Keep it small and specific with a healthy air of skepticism. Stay humble while you do this. The app is the way that it is for a reason, so be curious, not judgmental. Treat the audit as a feasibility study. If there is more scope or complexity than you first envisaged, be prepared to label the project as not feasible and walk away. Yes, even if you have already started writing code. Now, in our case, the application was more complex than we first thought, but that level of complexity was in unused features, and the audit helped us make sense of this and to get us to a bare bones version 0.9 implementation. When it comes to the tech stack, make a good enough choice in the context of your company and team. Rewriting or porting an application comes with enough risk as it is. Adding a new or an unfamiliar technology to the mix is just adding another layer where things can go wrong. Add value to your stakeholders as early as possible. Don't be afraid to experiment. For example, scope out a functional spike related to a pain point for your users. Put it in their hands. What do they think? And lastly, don't be afraid to step up and do something scary. I can't promise you that it will work out the way that you wanted, but I can promise you that you will learn something about yourself. My name is Adele, and thank you so much for your time.